Welcome guys, this is another video on math for quantum mechanics. Today we're going to find the Fourier series of this function. It's a very simple function, and to find the Fourier series we have to apply this formula. And basically we need to find the coefficients a0, an, bn, and the coefficients are given by this formula. So if you want to learn quantum mechanics, definitely you're going to see Fourier series and Fourier transform when you try to solve the Schrodinger equation. And as you know, the Schrodinger equation is the main equation in quantum mechanics. So if you want to know quantum mechanics, you have to know Fourier series and Fourier transforms. So let's start with the first coefficient, a0. It's given by this formula, and we have that a0 it's equal to 1 over pi integral from 0 to 2 pi of f of x, right? What's f of x? It's equal to this. So it's x squared dx, a very simple integral. We have 1 over pi x to the third, and all this we evaluate from 0 to 2 pi, and once we evaluate this we get 8 pi squared over 3. So that's a0. Now what is an? For an we use this other formula, and it's gonna be a little bit long, so you have to be patient and try not to make mistakes, because we're gonna use integration by parts twice. Integration by parts is given by this formula. dv equals u times b minus integral of v du. Alright, so like I said, we're gonna do this twice, and you have to be careful not to make mistakes. So an is given by 1 over pi integral from 0 to 2 pi. It's a lot of writing. X squared cos n x dx. Now here you have cos n pi x over L, but what is L? L is given by pi in this case. So once you plug pi here, this cancel and you're left with cos nx. That's why you have this formula right here, and now this whole thing. So we have to do integration by parts. We let u equal x squared. We differentiate this, and this 2x dx dv, it's equal to cos n x. We integrate this sine n nx over n. So we apply the formula, and we have 1 over pi x squared sine nx over n integrated from 0 to 2 pi minus integral from 0 to 2 pi sine n nx over n 2x dx. All this multiplied by 1 over pi. So here's a good idea to label this so we don't get confused. I'm going to label this 1. I'm going to label this 2. And the remaining term, I'm going to label it p equal 3 plus 4. You're going to see why in a second. And the reason is because I have to do integration by parts again for this integral, right? So if you don't label it, it's very hard to keep track of all the terms. So we do integration by parts one more time, and then we're gonna let u equal 2x, du equals 2 dx, dv equal sine nx over n, and b is equal to minus cos nx over n squared. So we apply the formula, and we have minus 2, negative, because you have this negative here, 2x cos nx over n squared, 0 to 2 pi, plus 2 0 to 2 pi cos nx over n squared dx. All this multiplied by this negative. So let me clear this negative here. We get 2x cos nx over n squared integrated from 0 to 2 pi, and minus 2 integral from 0 to 2 pi cos nx over n squared dx. So now I can label this as 3 and this as 4. Now, what is 4? 4 is given by this integral, and we have minus 2 sine nx over n cube, because we have n squared evaluated from 0 to 2 pi. Okay. So now we have to add 1, 2, 3, and 4. And once we do that, we have 1 is 1 over pi. And what is 2? 2, as you can see, when you plug 2 pi into sine is 0, and you plug 0 into sine is 0. So this is 2, 0, this is 1. And what is 3 now? 3 is here. We have to plug these limits into this function. We get 4 pi cos n 2 pi over n squared. And once we plug 0 here, it gives us 0. So we're left with 4. What is 4? This is 4. And if you plug these values into sine, it gives us 0. So plus 0. And we simplify a little bit. We have 1 over pi, 4 pi cos n 2 pi over n squared, and this 2 pi cancel. We're left with 4. Cosine 2 pi is 1, so the answer is given by 4 over n squared. Alright, so that was quite long. Now we have to find the VNs, and I'm not gonna do it because the video is gonna be too long, but basically it's the same idea as here, but instead of cosines you have sines. So you also have to apply integration by parts twice, and as a result you get that Vn is equal to minus 4 pi over n. Alright, so now we have a0, an, and bn, and we're ready to find the Fourier series. And the Fourier series of f of x equals x squared is equal by 4 pi squared over 3. Notice that here a0 is 8, but a0 is divided by 2, so 8 divided by 2 gives us 4, plus the sum from 1 to infinity. Now we need an 4 over n squared times cos n x minus, because bn is minus, 4 pi over n sine nx. One more time, we have sine nx and cos nx instead of this, because pi is equal to L and this cancels. So once this cancels, you get cos nx and sine nx. So this is the Fourier series of this function, and like I said before, all you have to do is find the coefficients in this formula right here, and then you plug it into the formula and you get the Fourier series. It's not hard, it's just that it can be long, because as you can see, this is a very simple function, and this is just half of the problem. You have to find bn, and it's the same length as this basically, but it's the same idea. You just have to do integration by parts twice, and you get this coefficient, you plug it here, and you're done. So one more time, if you want to know quantum mechanics, you have to know Fourier series and Fourier transforms. I'm gonna do another video on Fourier transforms soon, so if you wanna watch that, you can like and subscribe, and I'll see you on the next video.